Okay, so I worked out the envelope of one parameter family of curves for the general equation of a circle in the previous video, and I had promised to do a quick revision of it in this video. Alright, so we have x minus a squared plus y minus a squared equal r squared. That's the general equation of a circle. A, this A is how much the circle shifts from the origin in the x direction, and this is how much the circle shifts from the origin in the y direction, right? R is the radius of the circle. So in step 1, write everything as f of x, y, z equals 0. In step 2, differentiate with respect to the parameter a. Step 3, we solve simultaneously. The envelope would be two straight lines that are tangential to the family of circles. In this case, our curves are circles, right? Now, we write back the equation here, and we write everything on the left equals 0 on the right. Differentiate with respect to a. So using the chain rule, 2 times x minus a, that's the outside function. The inside function is x minus a. We differentiate with respect to a, we get negative 1, so we multiply by negative 1 plus. Same thing happened here. Bring down the 2 times y minus a times derivative of y minus a with respect to a is negative 1 minus r squared is just a number, so when you differentiate you get 0. So negative 2x minus a minus 2y minus a equals 0, right? Multiply out the bracket negative 2x, negative 2 by negative a is positive 2a, minus 2y plus 2a equals 0. Then here, negative 2x minus 2y plus 2a plus 2a is 4a equals 0. Factor out, so we have negative 2 outside the bracket, x plus y in the bracket. Subtract 4a from both sides, we get minus 4a equal minus 4a. Divide both sides by negative 4, and then simplify, you get x plus y over 2, right? Then here, a is x plus y over 2. Substitute it into the equation. You get x minus a, but a is x plus y over 2, r squared plus y minus x plus y over 2 r squared equal r squared. But use common denominators to work out the fractions inside each bracket that is squared. So we have multiply top and bottom here by 2. So we have common denominators, something over 2 in both cases. We have 2x minus x plus y over 2, and then 2y minus x plus y over 2 here equal r squared. So here now, the brackets, you have 2x minus x minus y over 2 plus 2y minus x minus y over 2 equal r squared. It simplifies to this, right? And then when we square each bracket, the 2 under the bottom is squared to 4. We multiply both sides by 4, and then we get x minus y squared plus y minus x squared equal 4r squared. When we multiply out the brackets, this is what we get. Continue up here. So we put the x's together, the x squares together, the y squares together, and the xy's together. We see that we get 2x squared minus 4xy plus 2y squared equals 4r squared. Just divide both sides by 2. We get x squared minus 2xy plus y squared equals 2r squared. Alright, then we consider this equation in the general form of a quadratic. Well, the left hand side, we consider the left hand side in the general form of a quadratic expression, ax squared plus bx plus c, where our a is 1, our b is negative 2y, and our c is y squared, right? And we use the AC method to factorize. And we get x minus a equal 2r squared. In the previous video, it had slipped me to bring down the r, but here, I'd remember a little later. To bring down the 2. So yeah, x minus y times x minus y equal 2r squared. Which means x minus y squared equal to r squared. So you square root both sides. You have positive and negative. 2r squared. That becomes positive and negative square root of 2 times r. When subtracted x from both sides and then multiply both sides by a negative 1 to move from negative y to positive y. So y is equal to x plus 1 minus the square root of 2 times r squared. So that is the envelope. This here is the envelope of the parameter of curves to this, to this general equation of the circle. All right. So once you have that, you have this. All right. So you can review it, and later on we're going to look at some. Well, I did one example with numbers before, but we're going to look at some more examples later on using numbers. So I'll see you then.